So let's talk about vector. So we have here another topic, the vectorial representation of harmonic motion. Now, going back, so this is already being discussed sa P6 ninyo. So let's have a quick review of that one. So what is vector? So usually, uh, vector is defined as, so it is defined as the specification that gives both direction and magnitude. So vector must have a direction, and it must have also a magnitude, so at the same time. So without a magnitude, without direction and magnitude, so it is not qualify as a vector. So katulad ng we have temperature. Okay, so temperature, usually the temperature is not a vector because there is no direction. So temperature is quantified as a scalar quantity, and we cannot say na hindi mo naman pwedeng sabihin na the temperature at the east is ganito at the temperature of 80 degrees Celsius acting on the east, so towards an angle. So there's no such a thing. So that's why it is considered as a scalar quantity. Now, velocity, on the other hand, is called it a vector. So it provides magnitude and direction. Let's say 10 meter per second at, let's say, the velocity of 10 meter per second. So this is a velocity. Now, at what direction? So at the east, or 30 degrees, 90 degrees, traveling at 10 meter per second. Now, also, the distance is also a scalar quantity. So it just only provides it just only provides how much is the the space, or we call the gap. So that is a distance. Now, on the other hand, vector. So let's write this one. So vector, we have your velocity. Okay. Then also the distance, if we're going to say displacement. So when you say displacement, ito ang ginagamit natin sa vibration. So we will, from the previously, we'll be talking about the displacement. So the displacement is a vector. So how much you put the displacement at what angle, at what degree. Okay. So that is a vector. And also acceleration. Acceleration is also a vector. Okay. So how much is the change in velocity of an object traveling? So that is also a vector. So going back here, so vector, so that it is a unit that provides a direction with a magnitude. And we use okay. Let's add this one. So we have for specifying the vector. So we have the positive and negative sign. Positive and negative sign to indicate the vector direction also. So for example, we have a horizontal motion. So we have let us an arbitrary specify the right that is being. So usually in our mechanics, going back, so we have your x, we have your x and y axis. Okay. So usually this quadrant we have the positive here. So we have your positive y, and we have your positive x. Okay, still remember that one. And the other side, we have your y, which is negative, and we have your x, which is negative. And this side, so we have your y, which is your negative value, and we have your x, which is your positive value. On the other side, so we have your y, which is negative, and this side also going there. So we have that value, so that is x also. Here is positive, and we have here going on this side. Okay, going down here, so we have a negative value here. So this is this side, this is negative x, and this is we have your positive x. Sorry, we have here sorry, I forgot, this is positive y, and we have your x is negative. Now we have on this quadrant, we have both negative and y and x. Okay, so that is include the direction of the vector. So going back to the vector representation of harmonic motion. Now the harmonic motion, so it can be also represented by means of the vector. So we have your vector here, for example this one. Going back here, we have your vector OP. In here, so we have here your vector, no? So we have your vector OP, so we have the symbol here, the arrow. So we have your vector OP. So we have the magnitude of A, okay, magnitude of A, so this one, and the rotating, so we have a rotating value of the angular velocity here, rotating an angular velocity with respect to time, and the projection of the tip of the vector, this one, okay, the projection at the vertical axis, given that our vertical projection. Okay, so the projection on the vertical axis, so we have here your y at this side, so that will be the a sine of theta, a sine of theta, which your theta is the angular velocity. So we have here the projection, so we have your magnitude, so I'm going to draw that one. I'm going to draw that one here again. Okay. So we have here, okay, the vector OP, okay, that one, and we have your magnitude, which is A. Then it is called this had an angular velocity, or we have here a theta that is acting on this side, angle at this side. So we have your theta here. Then this theta, which is equal to, since it is rotating, so we have an angular velocity. Now our theta is equal to the angular velocity times the time. Okay. Now so the vertical projection of this one, so vertical projection, so we're going to do that one here, projection here. So remembering from your trigonometry, we have your SOHCAHTOA. So this is the easy way to remember that one, SOHCAHTOA. So we have your theta, okay, and we have here your hypotenuse, which is your A, okay, and we have your opposite. So this is your projection at the vertical axis, which is your y. Then we can say that our sine of theta is equal to your opposite, where your opposite is your y. Then it is divided by the hypotenuse, which is the value of your A. Now rewriting our equation, so that will be sine of theta times the so I'm gonna change that one. So that will be sine a sine of theta, okay, where our sine of theta is equal to the angular velocity times time. So we have the a sine times the angular velocity times the time. So that will be the projection projection on the vertical axis. Now for the projection on the horizontal axis, so that will have here your x at this side. So that will be the the adjacent. Okay, so here adjacent, and we have your hypotenuse. So we can use this one, your cosine of theta. So that will be the adjacent. That will be your x, and we have your hypotenuse, which is your a. So rewriting our equation, so that will be your x is equal now to a cosine of theta, where your x is equal to a cosine the angular velocity times time. So that is the value, okay, of the theta. So this is the representation of a harmonic motion by means of vectors. So we have here the magnitude and the direction of the vector OP at a magnitude of A. So you will notice here, class, no, the vectorial representation. So it will require the vertical axis, or let's say the vertical component, and the horizontal component to define the representation of the harmonic motion in terms of vectorial by terms of vectors. Complex number representation of harmonic motion. There, it is more convenient to represent the harmonic motion using a complex number. So we'll be using a complex number to represent that one. So any vector, so we have your vector, which is your this one, okay, sample of that one. Any vector in the x and y plane can be represented as a complex number. So we have your vector, which is your x bar vector, so it can be represented as your a plus, imagine, a plus your I b, where your I is equal now to the square root of -1, and our a and b, so your a, so this denotes the x component, so this will be the x component, then our b, so that will be your y component, so this is represented on x and y axis. So now the components a and b, so they are called the real and imaginary parts. So we call this the real, and so this is the real and imaginary parts of vector x. Okay, so this one. Now if you're going to graph this vector, we call it the complex number in a graphical representation. So this is our y-axis, this is your y-axis, so this is now your this is our imaginary. Now our x-axis, so this is our real, so that is from your real and imaginary. So to have a quick review, no, class, so how are we going to use this one, this complex number, no? So reviewing from your algebra, okay, so usually this is from algebra. So if we have, So if we have a value which is negative 5 plus 12i, so how are we going to plot this one sa coordinates nyo? So usually we have here, so this is your a value, and this is your b value. So we have negative 5, which is your a, is the x component. So we're going to bilang tayo from starting from 0 here. So we have 1, negative 2, 3, 4, 5. So this will be your negative 5. Then we have your b, which is your y component. So we have your y here. So that will be 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so we have the value here. So the intersection of this one and this one. Okay. So we have here the intersection. I'm gonna color this one as a yellow to represent. So para mag-iba yung kulay niya. Okay. And this one also, we have the intersection here. Change the color. So we have the intersection niya is dito. Okay. So we have the point here. Now, to get the absolute value, to determine what will be the absolute value of negative 5 plus 12i. 12i. Okay. So we need to determine the hypotenuse. So we're going to draw a right triangle here. Okay. So we have now a right triangle dito. Okay. So by Pythagorean theorem, so we all know that our to get the hypotenuse, so that will be the square the equation of c squared is equal to a squared plus your b squared. So that will be the hypotenuse, or this is will become the square root of your a squared plus your b squared is equal now to the value of your a. So that will be negative 5 squared plus the value of your y. So that will be 12 squared. So finally we have the value of, so we have the value which is 13. Okay. So the absolute value of the negative 5 plus 12i, so we have the 13. So 13 is the value here. So if you're going to draw the direction here, so we have a mob from negative 5, so we have a mobile going here. So if you're going to draw the direction starting from here, from 0, we have negative 5 going to the x-axis, then going up. So we have the 12 for your imaginary. Okay. Then to get the value, so we have your absolute value of that one. So this is a quick review, no, class? So from, since we will be dealing this one, your complex number, so this is a quick review from your algebra. I think it is from algebra or in physics, maybe. Okay. Now before we proceed to the other topics, going to the complex numbers, so we need to familiarize, try to understand that we have the we'll be using this one as we go along, so as we proceed. So we have to remember that your I, so that is equal to the square root of negative 1. So kanina sinabi ko na yun. So already stated 1. Now, so we have, if we're going to square your I, so that will be equal to -1, since it will be cancelled out. So, or you can transpose this, transpose the square root of square root, that will be in reverse na ito sa kabila, that will be squared. So this is equal to -1. Now for the I raised to cube, so that is equal to, if we're going to break down that one, so we have, I'm going to break down natin to, so we have your I will be squared, no? So it will be multiplied by I, which is raised to 1. So when I is raised to 1, so we have the value, same value of this one. Now if you're going to expand this one, we have your I squared, so this is equal to negative, so natin to, that will be -1. Then this one we have, so this will be, yeah, I, or we can say this is also equal to, so since it is I, this is square root of -1, so let's say it is a 1, so it will be now equal to -I. Now for I raised to 4th, so this is, we're going to break down this one, so we have I squared, then multiply it by I squared. So let's say, and this will become now, the value of this one is equal to -1 times the -1. Okay, so we have the value of +1. This is positive. Okay, so the reason okay, we'll be using this one as we go along. Okay, so please familiar with this one. So we'll be using these values mostly, yung ito. So I'm going to highlight this one. So it's very important. Okay, so going back here to the vector x, so we can also express yung values natin ito using yung values na nakuha natin dito before. So this is x. Okay, so your x and y component, x and y, so we have your x and y component, so we can substitute that one in sa vector natin for representation. Okay, so doing that one, so I'm going to write here, so our vector x, okay, so that will be a plus, that will be I times the b. So we have your vector, which is the value of a, going back, so ang a natin, that will be, that is the x component. Now our x component will be a cosine of theta, so we can use that one here, so that will be a cosine of theta, then plus your b, so our value natin ng b natin dito, going back, so which is y, that will be a sine of theta. So we have your a sine of theta, then the I, okay, so we have the representation of this one. Now the value of your a, so this one we have your, which is the absolute, which is the hypotenuse, no? So the value of your a, so that will be the square root, or that will be a squared plus your b squared raised to 1/2, okay, or it will be also equal to a squared plus your b squared. Now for the angle, so we have your, so since this is, going back, so this is already this one, so we have your adjacent and adjacent, so we have your SOHCAHTOA, using your SOHCAHTOA, so we have your opposite value, and we have the adjacent value, so we'll be using the tangent. So we have for the theta, so we have your tangent of theta. So this is TOA, no? So your opposite, looking at this one, so we have your opposite here. For example, this is your theta, right? So we have your opposite, which is your B over A. Okay. This is your adjacent, this is your A. Now to get the theta here, so simply we have your shift tangent of theta. So this is a review na lang class. Okay. Now, so since we have here the values of your I until to the fourth, noting that one, so we have your cosine of theta. We can also expand in forms of series expansion or Taylor series of expansion your cosine of theta. So reviewing from your cosine of theta, call it Taylor series of expansion. So reviewing from your advanced mathematics, so we have this equation, the equation for Taylor series of expansion. So we have the function of x, which is equal to the function of a plus the first derivative of function of a divided by 1 factorial. So that will be x minus a plus the second derivative, the function of a, divided by 2 factorial. That will be x minus your a. So this is raised to squared. Then plus the third derivative of function of a divided by the 3 factorial times your x minus a raised to q plus and so on. So the Taylor series of expansion of the cosine of theta. Okay, so for the function of x, so we have your cosine of x. Now, so the derivative of your cosine is equal to negative sine, and the derivative of sine, it will be equal to cosine. So eventually, so we're going to find the function of theta here. So the function of your theta, so we have your here the function of a, so that is the first derivative, the function of a divided by 1 factorial, and this is will be your theta minus the value of a plus the second derivative. Okay. So that will be the second derivative of the a divided by 2 factorial, then we have your x raised to squared. Okay, so this is theta, sorry, it's theta. Okay. Then it will be third derivative. So we have your a here divided by 3 factorial, then we have your theta minus a times raised to 3 plus and so on. Now for the function of x, okay, for the function of x, so this is the function of theta. Okay. So we have your cosine of theta. Then for the first derivative, we have your cosine of theta of the function of theta. So we have your so this will be negative sine of theta. Then the third derivative, the second derivative of function of theta, so this one. So derivative of this one, it will be negative cosine, so it will be reverse going back, so it will be negative cosine of theta. Then for the third derivative, so of theta is equal now going back, so it will be positive sign, since it is your cosine, derivative negative, so it will be multiplied by, so if you're going to change the, since it is already cosine from the second derivative, now we're going to derivative the third. For the third derivative, we're going to derivative the cosine, so it will be negative sign, so it will become now positive sign of theta. Now from there, so we have now your cosine of theta is equal to cosine, which is your a, no, function of a, then it will be minus sine of a, okay, divided by 1 factorial, then multiply by x, or let's say this is already not x, but theta minus a, this is also minus cosine of a divided by 2 factorial times theta minus your a squared plus sine of a divided by 3 factorial times theta minus a raised to q plus, and so on. So we're going to let the value of your a, which is equal to 0. So it's more convenient because you know that the cosine of 0 is equal to 1, and we have the sine of 0, which is equal to 0. Now, so substituting that one to our equation in here, so let's do that. So we have your cosine of theta is equal to your cosine, so cosine of 0, so automatically this brings us to cosine of 0, that will be equal to 1. Okay. Then we have sine of 0 with the value of this one, so it will be 0 divided by the 1 factorial, then multiply by theta minus the value of 0. Okay. Then we have next the cosine of 0, it will be equal to 1 divided by 2 factorial, then it will be multiplied by the value of your theta here minus 0 squared, plus we have sine of theta, which is 0, so we have your 0 divided by 3 factorial, then we have your theta minus the value of 0 raised to q plus, so this is 1. Next we have then we have your 1, so since yung kasunod dito it will be cosine, no? It will be 1, value niya cosine of 0, that will be 1 divided by 4 factorial times your theta minus 0 raised to 4th, then plus, and so on. Now to evaluate this one, so we have now your cosine of theta is equal to 1 minus here, so this is already going to cancel out this one, so I'm gonna mark this one, so this is 0 already, and we have this one. So it will be theta squared negative theta, no? Negative theta, oh this is minus, sorry. Theta squared divided by 2 factorial. And we have here, so this is be theta squared divided by 3 factorial. Then we have plus dito, then we have theta to the 4th divided by 4 factorial. Okay. Sorry, we have here, so this is already 0 since it is 0. Okay, this is 0. So sorry about that one. I'm going to remove this one. So we have the answer for this one. Now this is now equal to, okay, so using the imaginary or complex number, so this is now equal to 1. So we have here theta squared. So remembering that if we're going to input the I here, so this is negative, no? Going back kanina, so it will be theta squared. So we have your imaginary here kanina, so we have this one. Okay, so we'll be using that one to represent none. Okay, so it will be positive now since it already acquired the theta, the I squared. So 1 plus theta, so that will be your I, okay, your theta. So we try to regroup this one or palitan ng value to ano yan, kinuha natin negative and we form it the I. So this is I squared. Okay, since your I squared, it will be equal to negative 1. Square root of negative 1. Negative 1. So this is 2 factorial. Then we have now for number 4, I raised to the 4th. So going back, so we have here I squared is equal to negative 1. So we extract this one to form this one. Now for the I to the 4th, it will be positive. So we can represent this one also the same way. So this is positive 1. So going back there kanina, so we can express this one as I raised to I theta raised to 4th divided by the 4 factorial. Okay, so we have the series expansion here and expressing it in a complex number. So I'm gonna box this one. Okay. Now for the sine theta Taylor series of expansion, so I'm bringing down the equation here for the Taylor series of expansion. Now for the substitution of the function of theta, so since we are considering that one, so we have here the substitution of the theta here. Then the values of the function of sine of theta. Firstly, we have so the function of theta, so it will be equal to, so we have the sine of theta here. Okay, then the first derivative of function of theta here, so we have, so this is will be sine, so we're going to revert this one, so it will be cosine. So this is will be derivative of the function of sine of theta, it will be positive cosine. Okay, then the second derivative of the function of theta, so this one of the sine. So we have so this is will be, so if cosine, it will be negative sine of theta. Then for the third derivative, okay, so function of theta, so we have, so this is already negative sine, so it will be positive cosine, then multiply by so it will be negative sine multiplied by already third derivative of sine, it will be positive cosine. So since it is also negative here, it will become negative here, so we have negative cosine of theta. So substituting that one to the equation, so we have the sine of theta is equal to since the function of theta here, we have sine of theta, so it will be sine of a, then plus the first derivative, no? This one will be cosine, okay, so it will be cosine of a divided by 1 factorial, then we have your theta, okay, minus a, then plus the second derivative, so we have your second derivative, it will be, so this negative, sorry, change this one, so it will be now sine of a divided by 2 factorial, so this one, the second derivative, okay, second derivative, negative sine, then we have your theta minus the a squared plus the third derivative, so it will be negative again, change this one, it will be negative cosine of a divided by 3 factorial times your theta minus the a raised to cube, and plus, and so on. So let's use let a, which is equal to 0, so we all know that the cosine, of 0, again, this is equal to 1, and we have the sine of 0, which is, this is 0, which is equal to 0. Now substituting that one, so we have now your sine of theta is equal to the value of sine of 0, so it will be 0 plus the cosine of 0, so it will be 1, so 1 divided by 1 factorial, then multiply by, this is will be multiplied by your theta minus the value of 0 plus, this is minus, so it will be sine, this is already 0, so it will be 0 divided by 2 theta minus a, so this is 0 squared minus the cosine of 0, it will be 1 divided by 3 factorial times theta minus 0 raised to cube, then plus, and so on. So we have now, so simplifying our equation, it will be, so this is 0 theta divided by 1 factorial, so this one, so this is already 0, so let's cancel that one, this one 0 already, ito. Then minus, we have it will be theta raised to q divided by 3 factorial, this is 4, 3 then this is also equal to yung value na yan. So this is already theta. So let's say that this is I. We forgot to put here that Taylor series of expansion, which is your I. Now we just only enclose that one, yung I. So this is, we're going to put here the I here, then this is your I, then properly enclose this area. Okay. So we have your I here. Then we have your I here, we have your I here, and also we have your I here. Okay. So we have it now, that one. Now I'm going to add here. Going to add for the other side here, since we have the fourth derivative. I'm going to add the fourth derivative. So we have the fourth derivative, 1, 2, 3, and 4 function of theta. So this is so from cosine, so it will be positive, since here we have positive. So this is now will become negative sign cosine. It will be cosine. It will be now positive sign of theta. Okay, for the last one part here, where is this one? So I'm gonna plus here the third derivative, the fourth derivative, 1, 2, 3, and 4 function of a divided by the fourth factorial. Okay. So it will be fourth factorial. So the sine of theta, it will be 0. So I'm going to add this one. Then it will be theta minus a raised to 3. We have 4. Then I'm going to add another one here. Fifth derivative, 1, 2, 3, this is 4 and 5. So we have your theta here. Then we have, so this is will become not sine. So since sine, it will be now cosine of theta. So it will be added here. So I'm going to add here plus the fifth factorial, 1, 2, 3, 4, 5. So we have your function of a. This is become now fifth factorial. Then it will be theta minus a raised to fifth. Okay, so I'm going to add that one. So from here, I'm going to change this one to that one. So I'm going to include the values here. So from here, this is 3. Now so we have the cosine of a from 3 factorial. Then we go to fourth factorial, fourth derivative. So we have the function of a for the fourth derivative. So it will be sine of a now divided by the fourth factorial times your theta minus the value of a raised to 4. And we have here for the fifth derivative. So we have cosine of a divided by the fifth factorial times your theta minus the value of a raised to fifth. Okay, so I'm gonna include this one also here. And then I'm going to, forgot to close the bracket here. So let's continue this one. So we have the sine of a here. So since we have here, so sine of a, so it will be 0. So 0 divided by the fourth factorial times your 0 theta minus 0 raised to 4. Then plus the cosine of a, which is cosine of 0, it will be 1 divided by the 5th factorial, then we have your theta minus 0 raised to 5th. So close parenthesis here, and we forgot to add. I'm gonna change this one, then the plus here, since it is continuous, so plus, then close this one, and this one I forgot. Add it now, so this will be plus, and so on. Okay, so replace this one, so this is already 0, so this is only 0, so what we have here is the 5th, huh? So we are going to change this one also again and raise this one. So we have here plus the 5th. Okay. So plus the, how much is the one that is 5th, no? So theta raised to 5th divided by the 4, this is 5th factorial, then plus, let's say this will become plus or minus, depends, no? Okay, that one. Then so going back, this is now equal to, since we have your theta here, so we're going to distribute the values of here, this one. Okay, so we have your I. Okay, so we have your I here, I times your theta. So then we have theta raised to cube, this will be I, divided by 3 factorial, plus here we have also the I raised theta to the 5th divided by 5 factorial. Okay. Now this has become now our value, since we have here your I theta, so this is equal to positive, since the I raised to the cube, so going back, so I raised to the cube, we have negative I here doon, so substitute natin yan, it will become now positive. So this is will be I theta raised to cube divided by 3 factorial. Then we have plus this one, so raised to 5th is also equal to positive. So we have your I theta raised to 5 divided by the 5 factorial. Okay, so let's box this one. So for the final answer of this expression or series of expansion of I sine of theta. Okay, now combining this one, okay, so combining this equation and this equation, so it yields, so from the complex algebra here, combining that one, so we have your cosine of theta plus the I sine of theta. Okay, so combining the values of the previous one of the cosine series of expansion, so it will be this one. So it will become now your 1. So it will be 1. So 1 plus the value of your I here, theta, plus the I theta raised to squared divided by 2 factorial, plus this one, so we have your I theta raised to 3 divided by the 3 factorial, plus I theta raised to 4th divided by 4th factorial, then plus your this one, we have your I theta raised to fifth divided by the fifth factorial, and plus plus and so on. Okay. Now this form, okay, this type of form in Taylor series of expansion is equal to the value of e exponent. So this is equal to raised to I theta. So for this expansion. Now, on the other hand, if it is in the form of negative, so if this is your cosine of theta minus your I sine of theta, so this is equal to 1 minus your I of theta and plus I theta raised to squared divided by 2 factorial, and it will be minus by I of theta raised to cube plus 3 factorial and plus and so on. Okay. So this is equal to e raised to negative I times theta. So that is the values. Now, going back to our vector, from our vector, which is your vector of x, this is equal now to, so kanina we have this one. So if you're going to factor this one, so we have your a cosine of theta plus your I sine of theta. So dito natin ginawa yun. Okay, so going back to that one, so we have your a, let's try to erase this one. So we have cosine of theta plus your I sine of theta. Okay, so substituting yung values natin no, so we have now, we can express the vector into a is equal to, since the value of this one same the value of the series of expansion in cosine theta plus I sine of theta, so we can express this one as a times, or the magnitude times your I